Good evening. Welcome you all for today's session. Code converters. So here now we are in combinational logic circuit. The two types of circuits are combinational and sequential. Combinational, your output depends on your present input. In your sequential, your output depends on both present and previous outputs. Example for combinational circuits are all your adder, subtractor, multiplexer, demultiplexer, encoder, decoder, etc. So all 1-bit storage devices are your sequential logic circuits. So now we are in combinational circuits. So in the previous session we discussed about the code converters, binary to gray and gray to binary. Now we are going to discuss about BCD to XS3 and XS3 to BCD. So the difference between binary and BCD is we will represent binary from decimal numbers from 0 to 15, and in BCD we used to represent from 0 to 9. So XS3 to BCD. BCD to XS3, XS3 to BCD is nothing but we are going to add, if your decimal number is 0 to 9, our inputs will be B1, B2, B3, B4, that is our BCD, and XS3 we can represent by, see the variables are up to user design. We can represent any variables. For example, binary means as first letter B we can represent by B1, B2, B3, B4, and for XS3 we can represent E1, E2, E3, E4, right? So binary to XS3 means we have to add 3 x's in x's with the existing number. For example, if your number starts with 0, we have to add 0 plus 3. So you will get, your output will be 3 for 0. For 1, 1 plus 3. So your output will be 4. For 2, 2 plus 3, your output will be 5. Then for 3, 3 plus 3, your output will be 6. So accordingly, up to 9, we have to add XS3 with each numbers, that is your XS3 output. So binary BCD is your inputs and XS3 is your outputs. So up to 9, we have to add and frame this truth table. So we know our inputs and we know our outputs. For the outputs, we have to prove by plotting K-map, and we have to complete it with logic circuit. So for K-map, our outputs are XS3 like E1, E2, E3, E4. And for E1, E2, E3, E4, we have to plot the K-map for separately for E1, E2, E3 and E4. So while plotting K-map, we will get binary equation for all the outputs. Your inputs will be BCD, that is B1, B2, B3, B4. So while plotting K-map, your row will be B1, B2 and column you can take it as B3, B4. So your inputs will be the row and columns, and for the outputs you have to plot separate K-map for E1, E2, E3, E4. So after plotting K-map, we will get an output for each axis E1, E2, E3. So with that output, we have to draw the logic circuit. So this is the logic circuit of a BCD to XS3. So you can see the inputs are A, B, C, D or B1, B2, B3, B4, and your outputs will be E1, E2, E3, E4. As I said, it is up to designers. The variables may vary. If we represent by the alphabet starting with B for binary and E for XS3, it will be easy for understanding. So instead of this variables, you can use B1, B2, B3, B4 as your inputs, and E1, E2, E3, E4 as your outputs. So you can see the logic circuit here for BCD to XS3. So how many XOR gates? XOR, we are using XOR gates, OR gate, AND gate. In this logic circuit, we have all the gates like AND gate, OR gate and XOR gate. So as mentioned earlier, analysis and design part, our combinational is purely design, which started from truth table and ends with logic circuit, and our sequential is analysis part, starts from circuit and ends with truth table. So this is all about our BCD to Exercise 3. Thank you.